Hi, hello, namaste, my dear students. So, how are you all? How's your preparations are going on? I hope everybody is doing fine and you are practicing very well. So, as of the previous classes, today I come up with one more most important topic in PUC second year, that is calculus, especially the differentiation part, differential calculus. So, on this chapter, the questions will be asked on all the parts, that is 1 marks, 2 marks, 3 marks, 4 marks as well as 5 marks. So we have already discussed some of the important 5 marks questions on differentiation. So you can go and watch my videos. You can find the videos or classes of differentiation for 5 marks in the playlist, okay, for exam preparation. So today we'll discuss some of the most important topics for 3 marks. Okay, let us see one important example. So find dy by dx if x is given and y is given. So two equations are given. How to find the differentiation, that is dy by dx. So these kinds of problems has been asked repeatedly in your board exams for 2 marks compulsory. Let us see. So whenever two functions are given, x and y are two functions here, and the variables involved are theta, you can see. So both the functions will be defined for the same variable, that is either he will mention theta as a variable or sometimes he will ask t, small t also. Okay, let us see. What we do is, so differentiation when two functions are given and defined in the same variable theta is obtained as dy by dx is equals to dy by d theta divided by dx by d theta. So this is our formula to be obtained. You need to remember this. When two functions are given, we call this as a parametric form of equations. There are three forms: Cartesian, polar and parametric. When two equations are given defined in a single variable, then we call them as a parametric form of equations. So this is the formula to find the dy by dx. So first let us consider x, that is a into theta plus sine theta. Now just simply differentiate with respect to theta because we need dx by d theta. So differentiate with respect to theta. So x becomes, you all know it is dx by d theta is equals to, now as I have said in the previous class, function is there and along with in multiplication there is a constant. So there is a, now whenever a constant is present with the variable or a function, we call it as a friend, isn't it? It cannot be eliminated. So constant keep as it is. Now differentiate the function with respect to theta. Here it is theta. It is like x with respect to x. What it is? 1. Yes. Only the variable is difference. Now differentiation of sine theta. Differentiation of sine theta is cos theta. You got it? So this is our dx by d theta. Simple dx by d theta by using basic differentiations. Isn't it? Isn't it easy? Yes. Now consider y function. What he has given? A into 1 minus cos theta. Again the variable is theta. Again differentiate y with respect to theta because we need dy by d theta only. So differentiate with respect to theta only. What it becomes? Y becomes dy by d theta. Again from the function, a is a constant in multiplication. You keep a as it is. Now differentiate the bracketed value. 1 is a constant, there is nothing variable. 1 separately, one term. So 1 differentiation is 0. Minus cos theta differentiation is minus sin theta. Here it is, minus sin theta. This minus as it is, already given in the problem. Let us simplify. Minus into minus plus, a as it is, sin theta. This is your dy by, I'll write here instead of here. This is nothing but what? A sin theta. This is your dy by d theta. Isn't it easy? When two functions are given, observe the variable and find accordingly. Okay. Now equation number 1 becomes, because that is a formula to be substituted. Let us say dy by dx is equals to, first dy by d theta value, here it is, a sin theta divided by, dx by d theta is here. A into 1 plus cos theta. Okay. Now you can cancel A with A. You can cancel A with A. The remaining terms are sin theta in the numerator, 1 plus cos theta in the denominator. Now you should know the trigonometric basic formulas. Here we need half angle formulas. That is, sin theta formula can be written as 2 sin theta by 2 into cos theta by 2. You need to remember the formula. So this comes from sin 2 theta. And when we divide the angle by 2, it becomes half angle. So sin theta will be 2 sin theta by 2 into cos theta by 2. Similarly, 1 plus cos theta value is, so these are the half angle trigonometric formulas you should remember to simplify. Okay, sin theta is this value, 1 plus cos theta this value. Now again you cancel 2 and 1 cos with 1 cos, because in the denominator we have a cos square. What are the terms remaining? Sin theta by 2 divided by cos theta by 2. So sin by cos is nothing but what? Tan theta by 2. Angle as it is you need to keep. Sin x by cos x is tan x. Sin theta by cos theta by 2 is tan theta by 2. So this is our required dy by dx. Because you need to practice these kinds of problems, because you are going to face the same kinds of problems in your examination 101%. Just try to understand. So welcome back, my dear students. We'll see one more important example, and this is asked in 2025. So previous year question paper, this question has been asked. Again, this is included in the model question paper also. Let us see. Again, two functions are given as of the previous only. When two functions are given and he is asking dy by dx, and this is a formula to be remembered. You know already this, isn't it? Okay, let us see. Now first consider the x. Here it is, x equals to a into theta minus sin theta. Just differentiate with respect to theta only, because the variable is theta. Differentiate with respect to theta. So x becomes dx by d theta is equals to, again a constant with the variable as it is. Theta with respect to theta is 1, minus as it is sin theta differentiation is cos theta. And there is nothing to simplify. We'll keep it as it is. And this is your dx by d theta value. There is nothing to simplify. Right? Now consider the y value. Y is equals to a into 1 plus cos theta it is. Again differentiate with respect to theta itself. Okay. Now what it gives us? Y becomes dy by d theta is equal to a as it is. 1 differentiation is 0. You all know. Plus cos theta differentiation is, yes, it is minus sin theta. Isn't it? So let us simplify and write down here. I'll make it as a mark. So dy by d theta is equals to a as it is. So it plus into minus minus. So it will be minus a sin theta. So this is your dy by d theta. Isn't it so simple? Just basic differentiations. Now substituting in equation number 1. So dy by dx is equals to dy by d theta, here it is, minus a sin theta divided by dx by d theta. Here you can see dy by d theta is here, and dx by d theta, this value, keep it here in the denominator. So this is nothing but what? A into 1 minus cos theta. So can we cancel a with a? The remaining terms are sin theta and cos theta with minus sign. Minus sign as it is, again sin theta. We have used the formula in the previous problem. Same we need to use here. 2 sin theta by 2 into cos theta by 2 whole divided by 1 minus cos theta is a little bit different. So previous problem we were having 1 plus cos theta was 2 cos square theta by 2. When you have 1 minus cos theta, it is 2 sin square theta by 2. Only it is a matter of plus and minus. When it is plus, it is cos square. When it is minus, it is sin square. So 1 minus cos theta is 2 sin square theta by 2. Okay. Now observe what are the terms get cancels, 2 with 2 and sine with 1 sine, because in the denominator we have sine square. So the remaining terms are minus as it is, cos theta by 2 divided by sine theta by 2. Therefore, dy by dx is equals to minus of cot theta by 2. Why cot theta? Cos by sine is cot, angle is theta by 2. So this is your dy by dx. So isn't it so simple, my dear students? Okay. So if you get this, please follow the page and follow our channel, like, share and subscribe. Thank you. We'll see you with 2 more examples.